Alright, so in this video over here, we'll be talking about hyperbolas. So this may be a refresher for some of you, but I'm going to go through from the ground up, just so we're all on the same page. Now over here, this is our general expression for hyperbola. We have a over here, right in the numerator, should be by itself. The magnitude of this, or the size of it, so we're disregarding the sign by using the magnitude sign. That's the dilation away from the x-axis. So we're going to be elongating it up, or downward, away from the x-axis. Over here, now our h value is saying minus h, so we're going to reverse the sign and say that h is the horizontal translation towards the right, the positive x direction, or to the left as the negative x direction. Now, the k value, quite simple by itself, is the vertical translation. K is positive, we're going up. If we're subtracting by a number here, we're going down instead. And these two translations are very useful for determining the asymptote, which we'll look at in a moment. We'll tell you the location of your asymptote. Okay, and lastly, your reflection. So it doesn't matter if we're reflecting the x or y axis for hyperbola, because the shape is kind of like this, isn't it? It's going to be the first and third quadrant. If you're reflecting in either axis, it's going to look the same, because what's going to happen is if you're reflecting in the x-axis, you're flipping it upside down like that. And you're going to get the same graph if you flip it in the y-axis. So that's if the a value here is negative. And we're just going to draw this graph here, and we're going to compare it with the second one in just a minute. So for the first one over here, what I want to do for myself is I want to see all the transformations that are applied to this graph over here. So we're comparing to the graph y is equal to 1x. Sorry, not 1x, 1 on x. And how has this been transformed? So we're comparing it to this one. Okay, so we can see there's a h value over here. H value is, well, it's actually positive 1, because remember in our formula, the negative is already there. So if h is negative 1, sorry, if h is positive 1, that means our translation in the horizontal direction is positive 1. Translation in the vertical direction is negative 3. So we're going to the right, then we're going down. Okay, but what does this tell us? Remember that our our initial asymptotes look something like this. It's going to be along the x-axis, and it's going to be along the y-axis. So those were our initial asymptotes from the first graph over here. But when you shift your graph one to the right and and your vertical translation down by 3 units, this also means that asymptotes are going to move by the same amount. So our new asymptote, it's not going to be these blue lines, but rather, maybe I'll draw this in green instead. It's going to be 1 to the right, so the vertical one is now at over here somewhere. So this is x equals to 1, it's not x equals to 0 anymore. And we're going from y is equal to 0 all the way down to y is equal to negative 3 now. Okay, so that's one way to find the asymptotes. Alternatively, if you want to look for the asymptotes, the asymptote is really telling us what values of x or y make the other one undefined. So in what way can you make y undefined here? Well, you can say it's undefined when this denominator is 0. So you want to set, so alternatively, set x minus 1, the denominator, equal to 0. And over here, we know one of the asymptotes is 1. So this means that y is undefined when x is equal to 1. When you want to find out when x is undefined, make x the subject. So if you make x the subject here, you're going to have y plus 3 equal to 1 on x minus 1. If you have something like that, you just swap these two around, and we get this when we transpose for x. You can see that y plus 3 is in the bottom now. This means that we want to make y plus 3 equal to 0. If if y plus 3 is equal to 0, this means that y has to be equal to negative 3 for x to be undefined. So this is y the asymptote for when x is undefined, so y is equal to negative 3. Okay, so going back to the original problem here, we can see that this value over here is positive, so this means it's just going to be positive hyperbola. So we're going to be drawing in these two quadrants, top right, bottom left, and we're going to expect it to go through the x-intercept and a y-intercept. So let's work those out as well. Okay, so the y-int, we're going to set x equal to 0, and this is going to give us, well, 1 on negative 1 minus 3. Negative 1 minus 3 equal to negative 4. So we're going to chuck that over here. 0, negative 4 for our x-int. This one over here, we're going to see that y is equal to 0. And as a consequence, x, now when we transpose, we can probably just use this one over here. So when y is equal to 0, this means we have 1 on 3 plus 1. So this means we have 4 on 3. And this would be somewhere around So that's going to be our first graph. So that is for part A. Alright, what about part B? Now the only thing that's changed over here is instead of a 1, we have a 6 here now. So A value has changed to the number 6. What does this mean? So this means our dilation away from the x-axis, we're going to be stretching this graph outward now in the vertical direction. It's one way to interpret it. Okay, so let's get my red over here. Now, if the question asks you what the dilation is, of course, just refer to that number. I'm just going to make a note to myself. It's not necessary for graphing, but it's good to jot down whatever information you have. So if it's going to be stretching, we're going to expect these intercepts to be in a different location as well. Let's see what happens. For the y-int, x is equal to 0. Plugging 0 into here gives you negative 6 minus 3. Gives you negative 9. For the x-intercept, we would make y equal to 0. Solve that however you want, but you want to solve for x. So in this case, we're going to have y is equal to 0 over here. I'm going to add 3 to that side. 3 is equal to x6 on x minus 1. We're going to be doing a little bit of transposing here. So we get 3x equal to 6 plus 3. Did a little bit of cross multiplication, expansion, and added the 3 to the other side. And we find that x is equal to 3. Okay, so let's draw this new graph with a different color. Grab, let's say my purple out. Okay, so we have 3 around here somewhere. I'll label this as 3, 0. And I also have 0, negative 9. Okay, and when you draw this out, it's going to have a similar shape, except it's going to go past 2 different intercepts now. So in this case, when you pass through the purple dot, you can see it's above the black line in the first quadrant. In the third quadrant, it's going to be below it this time, because both these lines have been stretched away from the x-axis compared to the black graph. Okay, so that's the start of hyperbolas. It does get a little bit harder, but this is the basis for it, and the basic form you're going to need it in to be able to draw it very effectively and in the most efficient manner. Okay.